In this demo, we're going to see the continuous monitoring capability of CrowdStrike Falcon Host. It's important to know that we are constantly recording endpoint activity and streaming it to the cloud. This includes everything from basic file system and registry changes, process executions, network connections and DNS requests, to more advanced adversary activity like process injection and malicious use of administrator tools. The sensor does this recording all the time, whether the system is under attack or not. Let's start with PowerShell. The first thing we want to do is run some commands to perform basic recon on the system. I can profile the system with the system info command. Then I can get a list of all installed products so that I can look for vulnerable versions of software. And finally, I can get a list of all running processes. Then I can call a script that takes that data and zips it up into an archive called data.zip. Once that is complete, I'll just verify in the UI. Now, to get some more variety in our data collections, let's switch over to the Windows command prompt. Here, I'll copy that zip file out to a USB stick. Okay, so now I've done some recon on the system, zipped up the info, and copied it out to a USB stick. To get some more interesting activity recorded, let's go back to PowerShell and download a password stealing utility called gsecdump. Once the file is loaded, let's switch back to the command prompt to run it. You can see the access denied error. This is because the CrowdStrike Falcon Host sensor actually blocked the execution of this file. So we just performed a bunch of activity on a test endpoint. In the background, this was all being streamed up to the CrowdStrike threat graph. We can now use the Falcon Host UI to see this data displayed in real time. To see this, we'll go to the Investigate app. First, I can see that gsecdump is detected and blocked because it is malware. Second, I can see that my PowerShell activity was malicious enough to trigger a detection event. In command history, I can see the individual commands that I ran. For example, I can see that I used the command shell to copy my data out to a USB drive. I can also see that I dumped my system info data to a text file. In admin tool usage, I can, again, see specific commands that I ran. I can also see individual PowerShell activities. I can get details for all DNS requests and other network activities. I can see that data was archived into a file called data.zip. I can see that removable media was used. And finally, I can see all the connections that were made to various countries. Having all this data in the threat graph is useful for visibility, but we can actually use this historical data to provide additional protection. For example, let's say a system encountered a bad file on Monday, but you didn't know it was bad until Tuesday. With traditional solutions, that threat would persist until the next time you did a product update and ran a scan. With CrowdStrike in the threat graph, this need for scanning and taxing your endpoints goes away. Instead, we constantly scan the existing data in the threat graph against any and all new intelligence. So if we record an executable running yesterday and didn't realize it was bad at that time, we can display an alert in the UI as soon as we do know that it's bad. We call these retrospective detections, and they are a key component to our approach to next-generation endpoint protection. With this approach, CrowdStrike offers unrivaled visibility and protection.